Hello, everyone, and welcome back to the Equinor Summer STEM series. My name is Mr. Gonzalez, and this lesson is brought to you by Equinor. A little about me: I am a student at the University of Houston, presenting this lesson on behalf of Teach Houston, which is a program for aspiring STEM teachers. Today, we are going to be continuing our unit in chemistry. Now, in one of our previous lessons, we were talking about physical and chemical reactions, and today we are going to be discussing balancing chemical equations. So for today's mission, you are going to be continuing your research at Star Labs, and this time Cisco Ramon has asked you to run some simulations for him and provide him with the appropriately balanced chemical equations. Before we start getting into all of those simulations and balancing equations, though, I wanted to start us off with a short video, just to get our minds thinking. So before I push play, I want you to formulate your hypothesis to this question. Can we fit this entire piece of styrofoam into that little pan? You can pause the video now and push play when you're ready to continue. Now, there's no audio in this video, so I'm going to go ahead and talk you through it. Number one, there is no sort of camera editing going on, aside from the fact that this is being recorded at double speed, just to make it go a little bit faster. There is no CGI, there is no computer editing, there's no any sort of virtual simulation going on right now. This is actual real-life footage, and there's no hole in the table or anything like that, and you're going to see a different view from the side right now, just to show you that it hasn't just gone through the table. There is actually something inside the bowl, just like that, and you can see there is some sort of goop. So some questions I want you to think about through the duration of this lesson. Number one, what happened to the styrofoam? And number two, where did it go? Hopefully by the end of today's lesson, we will be able to revisit this and answer those questions. Remember earlier I said we were going to be running some simulations? Well, here we go. So our first activity is going to be from the PhET simulation, and we are going to be balancing those chemical equations. So the first thing you're going to want to do is go to tinyurl.com/chemistryphet, that is PHET. You're also going to want to visit our worksheet, so that is tinyurl.com/PhET worksheet 1. Now, after you open up the chemistry PhET URL, you should get a screen that looks like this. Once it loads, you're going to click on the introduction icon, and you're going to select your tool. So there is a scale, there's also a bar chart. You're going to either increase or decrease your atoms and molecules on either side of your equation until this not equal sign says that your equation is equal. Then after you finish making ammonia, you're also going to separate water and combust methane. So after you finish this one, you can go ahead and check out the key. Whenever you open up the worksheet, though, you will see all of the instructions typed up on your worksheet, and there's also a link to the key. So I will go ahead and leave you here for now. You can go ahead and pause the video and then return after you complete the activity. All right, everybody, welcome back. So by now you should have completed simulation activity 1. We're going to go ahead and take that one step further now because we want to be super thorough for Cisco Ramon. We're going to be using the same simulation from the previous activity. So if you closed out of that window, you can just revisit again. So tinyurl.com/chemistryphet. Same thing as previous, you're going to click on the right icon this time. So you're going to click on the game icon. You're only going to complete level 1. And again, you're going to use the arrows to adjust your quantities on either side of your equation. Then also be sure to open up the worksheet. That way you can keep track of all your calculations. And the key to this worksheet is also included in the instructions for that one. So definitely be sure to open that up on your window. And then once you complete this activity, go ahead and return to the video. You can pause now. Welcome back. Hopefully by now you have completed both activities 1 and activities 2. If not, definitely go back and rewind and check those out. That way we can go ahead and talk about the science behind everything we just did. So before we start even going into how to balance a chemical equation, let's discuss the components of those equations. At the most basic unit, you've got something like x plus y yields xy, where everything on your left-hand side is part of the reactant and everything on the right-hand side is part of the product. So while you were doing your simulations, you might have noticed these two different formats. So x2y versus 2xy. So now let's discuss what the differences are between the two. So on the left-hand side, this notation is known as a subscript. So that only applies to the thing it is immediately attached to. On the right-hand side, you've got a coefficient, and that applies to everything that follows after it. So if we were to count the number of elements on each side, you'll see that you have two x's on your subscript and only one y in this case. You can also pretend like there is a invisible 1 right here for your subscript, so you would have x2, y1. We usually leave that off because it's assumed that if there's no subscript, you only have one of that type. Next up, if we're looking at coefficients, this time you have two x's and two y's, because as we said before, the coefficient applies to everything after that follows it. So what happens if you were to try to change the subscript instead of the coefficient? Let's look at an example. If you have H2 plus O2 yields water, it is not the same thing as H2 plus O2 yields hydrogen peroxide. As you can see here, your first equation, H2 plus O2 yields H2O. This is not balanced because you have two oxygens on your reactant side, only one on your product side. If you were to just put a 2 right there, you would no longer have water, you would have hydrogen peroxide. This is why it's important that we only change the coefficients and not our subscripts, because then we are changing the identity of our formula. So I know I've been talking a lot about balancing equations, but what exactly does it mean for the equation to be balanced? In essence, your reactants should equal your products, or as we said before, x plus y yields xy, where you have an equal number of reactants and products on both sides of your equation. So now that we know what a balanced equation is, how do we balance it? So you may have noticed while you were running your simulations, there was a table on the first activity for you to count up the number of elements on your reactant side and the number of elements on your product side. So let's go ahead and break that down just one step further. So the first thing we did was we counted the total number of atoms for each element on the reactant side. So that was everything on the left. Next, we counted the total number of atoms for each element on the product side, which was everything on the right. Then once we had our numbers, we could see if there was anything different and then start adding our coefficients in order to get those two to be equal. And also you should have noticed that if there was a subscript and you added a coefficient in front of it, you had to multiply that coefficient by the subscript. I know that sounds confusing, but we will attach an example to this in a few. So, how do we verify the equation is balanced? If we look at this example that I provided earlier, we saw that you can't just add a 2 on the product side for H2O in order to balance it, because when you change that subscript, you change the formula, and we don't want to do that. So if we take the steps from the previous slide one more time, the number of atoms on the reactant side, we have 2 hydrogen, 2 oxygen. The number of atoms on the product side, we have 2 hydrogen, 1 oxygen. You can see here that our oxygen is not equal, so we can say that this equation is not balanced. You can go ahead and pause this video now and balance the equation. Hopefully you've had the opportunity to balance this equation. So if we are to look at it now, 2H2 plus 1O2 yields 2H2O. Let's go ahead and verify that this equation is now balanced. Again, we're just going to count the total number of atoms on the reactant side and product side, and we can see that we have 4 hydrogen, 2 oxygen on both sides of our equation. So now that we can see that it's equal all the way around, we have officially verified that this equation is balanced. So why is this important? Why does it matter that we're balancing equations and making sure that it's equal on either side? Well, this leads to a very important concept in science known as the law of conservation of mass. So I just want you to think about what this law might represent. You can pause the video now, come up with your hypothesis or your theory for what it means, and then go ahead and push play once you've got something in mind. So hopefully now that you've got something in mind, we can see that the law of conservation of mass states that mass is neither created nor destroyed. So with respect to our simulations from earlier and connecting that to balancing our equations, the total number of atoms before a reaction must equal the total number of atoms after a reaction, or in essence, our reactants have to equal our products. Because since mass is neither created nor destroyed, we can't have things just vanish into thin air. So now let's think back to the styrofoam experiment. Did the styrofoam really just disappear? No, of course not. So nothing disappears, and if we were to cite the law of conservation of mass, we know that the mass can't be created or destroyed, so it didn't just get destroyed all of a sudden whenever it was input into that solution. So if it didn't just disappear, what happened to it? A physical change occurred, and the styrofoam actually dissolved in the acetone. The acetone was the solution inside the little bowl. So this is similar to whenever sugar dissolves in water. So even though you can't see it anymore, it doesn't mean it's not there. So it didn't really disappear. It's still there. It's just dissolved. Let's go ahead and challenge ourselves one more time. This time we're going to visit tinyurl.com/chembalancingAct. You've got a list of scenarios. They are word equations, and what you're going to do is create a chemical reaction for the equation that is being described. You also want to ensure that your equations are balanced, and once you finish that, you can check out the key, which is included in the instructions to that worksheet. Go ahead and pause the video now, and I will see you when you get back. All right, welcome back. By now you should have completed our Chem Balancing Act activity, and now I have a list of some additional resources for you in case you want some more practice or a review. So you can visit the YouTube link on the slide if you want to just get another review of this lesson. It is Balancing Chemical Equations from Professor Dave Explains. And I've also included some links for additional practice. So there is education.jlab.org, which is another simulation software similar to the one that we used earlier, which is also included. So tinyurl.com/chemphet. You'll know earlier we only did the first level in the game, so you can also complete levels 2 and 3. Thank you so much for tuning in. I'm sure Cisco Ramon is going to be so happy that you completed those simulations for him. In the words of Benjamin Franklin, an investment in knowledge pays the best interest. Next time we are going to be discussing the types of chemical reactions, and I just wanted to remind everybody that we do have other videos in additional topics such as mathematics and computer science, so if you're interested, definitely be sure to check those out. My name is Mr. Gonzalez, and I will see you next time.